Okay, hello students. So I'm going to do this question. Just in case if you find, any, if you think this solution is incorrect, just mention in the comment section and also provide the solution. Don't just mention it that, okay, it is wrong. So that many other students can benefit, just in case I'm wrong. By the way, I'm not wrong. So I'll just feel like if this question I'm missing something, then you can definitely point it out. Okay. So I'm going to just start solving. So in the first column, they have provided problem statement. In the second and third, what you have to find out, they have mentioned. It's a matching the column, but for the last two part, no perfect column is there, like no match is there. Okay, into this and this. Fine. Let me just okay, let's start. In the first one, you have basically that pendulum sort of arrangement. Here you have mass m, it is suspended at O. Now you have to find the minimum velocity here so that this completes a one circular motion, one complete circle. Okay, and you have to find maximum tension as well, T max, right? And in so in the problem, they have just shown the creativity that that the whole system is in non-inertial frame of reference. Non-inertial matlab, the whole system is accelerating at some acceleration, okay, in some direction. Now, let's start. So I'll start with first problem. First one is just basic, okay, without there is no extra acceleration. So this is this first one. In the first one, you have a here suspension and here you have a mass m. Okay. Now you are trying to make a one complete circle. All right. So here you just have to make a free body diagram. What will happen here? Tension T, and you have to what you have to find. Did I explain? If I'm not, I'll just tell you the minimum speed required at this lowest point, U minimum, so that it completes one circle. All right, and maximum tension that you have to find out. Okay, I have told already. Fine. So here, what are the forces? Just at angle theta, just make a free body diagram. Okay. What are the forces? See, tension T is acting here, mv square by r, and here the mass mg is going to act, right? This is theta and this is theta. So this restoring component mg sine theta will be bringing it to the original position. And this in radial direction, everything would balance into what? T equal to mg cos theta plus mv square by r. Okay. Tell me one thing. What would be the value at theta equal to 0? That means at lowest point. This is going to be mg plus mv square by r. This is, by the way, T max. And at the highest point, what would be theta? 180. That would be T min. So T min would be minus mg plus mv square by r. Basically, cos 180 is minus 1, right? So in order to, so this part is important. In order to complete one circle, okay, one complete circle, this T min should not be, T min should be greater than 0, by the way. But in the limiting case, to solve it, you'll assume that it is 0, right? So what would be the velocity at the top? mv top square by r is equal to mg, और यहाँ से v top आ जाता था रूट जी आर. ये बेसिक फंडामेंटल 12th लेवल का है प्रॉब्लम, ठीक है. नाउ दिस इज द वेलोसिटी एट द टॉप. सो टॉप पे मिनिमम वेलोसिटी कितनी होनी चाहिए? रूट जी आर, राइट. Now, from energy conservation you apply at the lowest point, all you have is kinetic energy mu min square, and this kinetic energy will be equivalent to the gain in potential energy. So basically whatever energy is at the lowest point, it should be balanced by at the highest point. So highest point पे क्या हो जाएगा? Okay, I have to finish this soon. I'm recording it with Zoom and I only have 10 minutes. Fine. Half m v square, v top square, right? Plus mg into 2h, and 2h is how much? 2l, right? So यहाँ से, by the way, I have used r, right? So I'm going to use r. R is basically L, okay? The length of that rod. So 2r. So when you put Vt equal to root gr, so you will get mgr by 2 plus 2 mgr, and this would be 5 mgr by 2. All right? Fine. Now you will get U minimum is equal to root of 5gr. So for the first part, it is matching with which one? Let me see. First part is matching with this one, root 5gl. Okay, I haven't estimated the T max. Now, what would be T max? T max is basically mg plus mv square by r. V at the lowest point, right? So mv square by r, that would give 5 mg. That would be 6 mg. So for the first one, the matching is which one? This root 5gl and this one. Okay. Second, let's find out second. So here the whole system is accelerated by g by 3 in the upward direction, right? Okay, let me just use some other color here now. Purple. Okay. So here in this case, you are accelerating it by g by 3, and this is mass. So naturally, gravity is going to act downward, right? So what changes? A pseudo force is going to come, and pseudo force is going to act on this mass in the opposite direction. So what would be g by g plus g by 3? Okay, so I can bring in concept of g effective, but very quickly I will not do that, because here let's tension at the top. Let's try with the approach that I have followed earlier. जो पहले किया था वही करते हैं ना. mv square by r at the top minus mg, right? Now it is going to be mg plus g by 3. Okay. So here basically you'll equate it to 0. V top is going to come as 4 gr by 3. Okay. Now again you'll have half mu square and is equal to, this is min, mg plus g by 3 into r. No, mgh 2r plus half mvt square, m into 4g r by 3. This becomes 2 mgr by 3, and here 4 to the 8 mgr by 3, and 8 plus 2 10 mgr by 3, right? So u minimum is going to come as 20 mgr by 3, right? Basically the concept of g effective, right? So here g effective is going to be, so 5 into g effective, 4g by 3 into r. U min is equal to root of this, right? So this is basically root of 20 gr by 3 or 20 gl by 3, and then T max is going to come as m g effective is 4g by 3 into L. L is R plus mv square by R at the lowest point, right? Lowest point mv square by R in 20 gr by 3r. Okay, sorry. Here it is going to be just 4 mg by 3, right? So 4 mg by 3 plus 20 mg by 3, 24 mg by 3. This is going to be 8 mg. Okay. So which option matches with this one? So for second one, velocity is this and this. Okay. Now third and fourth. Before we move to the third and fourth, just remember in third one you have horizontal acceleration. In fourth one you have this root 2 into g, and this root 2, it seems like g is inside the root, but it is like this. Okay, I'm going to consider that. I think it is that. So okay, just in case you have noticed, fine. In the third one, let me use this green color. So far what we have done is we have considered only acceleration g effective only in vertical direction. Horizontal direction में क्या आ रहा है? It will not matter. You can just do force component and see. I have done it and I have seen. I'm just sorting it out. So what would happen is in the third case, there is g by root 3 is acting horizontally and everything else is same. Okay. So if you notice, you can draw the free body diagram here. So tension T, pseudo force is going to act here, mg by root 3, and mg is going to act here, mv square by r here, and this is the tangent. Okay. So if this is theta, this is theta, this is theta. So T plus mg sine theta, mg by root 3 is equal to mv square by r plus mg cos theta. When theta is 0, this pseudo force contribution of this pseudo force is going to be 0, right? And remaining everything is same. Okay. So here you will find that u minimum is what? Root 5g r, and T maximum is again 5 mg. Okay. You can see when theta is 180, again this is not going to change. So contribution of horizontal component is not going to matter. So for second, for this option, this one, none, sorry, for this one again this root 5 gl and this 6 mg matches. Fourth is even peculiar. Fourth option में क्या है ना? I'll just फोर्थ में क्या हो रहा है इसमें कि हॉरिजॉन्टल से 45 पे रूट 2g लग रहा है, ठीक है? तो इसका हॉरिजॉन्टल कंपोनेंट कितना आ जाएगा? बाय द वे स्यूडो फोर्स क्या लगेगा? स्यूडो फोर्स इधर लग जाएगा, जस्ट अपोजिट, राइट, इस बॉल पे। तो इसका जो कंपोनेंट होगा, ठीक है, वो आ जाएगा रूट 2g cos 45 यानी रूट 2. So they would be equal to g. G will be acting downward and G is upward and G is downward, and other G will come in this horizontal direction. अभी हमने देखा horizontal का कोई रोल नहीं है, no role of horizontal component, and vertical component of G effective is 0. Okay, so even if you will give a small push to the ball here, it will reach to the top, and what would be the tension at the top? mv square by r. There is no mg, vertical weight is not there. Okay. So, and what is the velocity? Any small velocity, it's like weightlessness in, in vacuum. So that is going to be there. I have some like you know, this is how it should be. Just let me know if you find any other solution or something you disagree with my thoughts. I'm open for suggestions. Okay, and just don't get angry or something. So fine. I'm just trying to uh, tell, trying to help you out as well as I'm learning also. So you understand here, there is no gravity, so mg component is lost. So what will be there? E, this is at the top, right?